This is the title of the problem. We're using a lasso regression model, a type of machine learning, to predict house prices. It's like a superpowered equation that uses information about houses, like size and age, to guess their prices. Here, I'll lay out the core question. Given some results from a lasso model applied to house prices, what conclusions can I draw? This is the core problem description. We're using the Python library, scikit-learn, and its lasso regression tool. The model's output is two coefficients. -0.05 for age, meaning for every year older, price drops by 0.05 units, and 0.12 for size, meaning for every square foot, price increases by 0.12 units. Alpha is a key parameter that controls how much the model simplifies itself. We set it to 1.0. This is one of the multiple choice answers. It suggests a negative relationship between age and house price, which is consistent with the negative coefficient found for the age feature in the model. Let's see if the data supports this idea. This is another multiple choice answer. It proposes that size and price have a positive relationship. The positive coefficient for size backs this up. This is a multiple choice answer. It suggests that setting the alpha parameter to 0 turns the lasso regression into ordinary least squares, OLS regression, a different type of statistical model. We'll explore whether that's correct. Let's dive in. This section explains the process and the methods needed to solve the multiple choice quiz related to lasso regression. I'll guide you through this. I'll start by explaining what those numbers, -0.05 and 0.12, actually mean in terms of house price predictions. Let's break this down into bite-sized pieces. This section is where you'll write your answers. You'll choose which statements about the lasso regression model are true based on the information given. Remember, we're looking at the coefficients for age, -0.05, and size, 0.12, and how the alpha parameter affects the model. You'll select the options that correctly interpret these results. Think carefully and good luck. This question uses a lasso regression model, a type of machine learning model, to predict house prices. I'm given the coefficients for age and house size and asked to determine the validity of several statements regarding the model's performance and characteristics. This involves understanding how the model's coefficients and the alpha parameter influence predictions. It's a test of your understanding of how lasso regression works. Here, I see that the coefficient for age is -0.05. This tells me that for each additional year of a house's age, the predicted price decreases by 0.05 units. The coefficient for size is 0.12, indicating that for each additional square foot, the predicted price increases by 0.12 units. It's important to pay attention to the signs, plus or, and the magnitudes of these coefficients. Here's where I get to put my knowledge to the test. I need to carefully evaluate the choices given and select only the statements that are supported by the given model coefficients and my understanding of lasso regression. I need to remember that lasso uses an alpha parameter for regularization, and alpha equals 0 leads to an OLS model. I see a negative coefficient of -0.05 for the age feature. This tells me that for every 1 year increase in a house's age, the model predicts a decrease in the house price by 0.05 units. It's important to note that the units depend on how the house prices were measured, e.g., dollars, thousands of dollars. This is a crucial insight. Here, we have a positive coefficient of 0.12 for the size feature. This means that for each additional square foot of size, the model predicts a 0.12 unit increase in house price. Again, remember that the units are the same as those used for the house prices. Pretty straightforward, right? I'm looking at the coefficients which tell the importance of each feature in the prediction of house prices using the lasso regression model. Specifically, we have coefficients for the age and size of the houses. These are the numbers that define how much each factor influences the price. The model used is a lasso regression model. Lasso stands for least absolute shrinkage and selection operator. It's a type of regression analysis that performs both feature selection and regularization. It's great for handling many features and preventing overfitting. Alpha is the regularization parameter in the lasso model. A value of 1.0 indicates a moderate level of regularization. It helps to prevent overfitting by shrinking the coefficients towards 0, which is really helpful when dealing with noisy data. A larger alpha value would shrink the coefficients more aggressively. I'm using lasso regression, a type of linear regression that shrinks coefficients towards 0 to prevent overfitting. Think of it like this: it's a more careful way to fit a line to your data, making sure we don't get too carried away by noisy data. This particular model predicts house prices using features like house size and age. I'm using the lasso regression model from the scikit-learn library in Python to predict house prices. The model gives me coefficients for age, -0.05, and size, 0.12, and I set the regularization strength, alpha, to 1.0. The negative coefficient for age, -0.05, tells me that, all other factors being equal, older houses are predicted to have lower prices. The coefficient's negative sign indicates a negative relationship between age and price. The positive coefficient for size, 0.12, means that larger houses are predicted to have higher prices, again keeping everything else constant. The positive sign shows a positive relationship between size and price. OLS is a simpler type of regression that doesn't apply regularization. If I set the alpha parameter in my lasso regression to 0, I essentially turn off the shrinkage effect, and my model becomes the same as an OLS model. Based on my analysis, the correct answers are B, C, and D. Each of these options correctly interprets the results of my lasso regression model. Actually, increasing alpha decreases the magnitude of the coefficients. Alpha controls the regularization strength. A higher alpha means stronger regularization, pushing coefficients towards 0. The final answer, considering the analysis and interpretations of the given statements, is B, C, and D. I'm confident in this conclusion. I'm assessing a lasso regression model. Lasso stands for least absolute shrinkage and selection operator. It's a type of regression that uses a penalty term to shrink coefficients towards 0, helping to prevent overfitting. The coefficient for the age feature is -0.05. This means that for each year a house is older, its predicted price decreases by 0.05 units, assuming other features remain constant. A negative coefficient indicates an inverse relationship. The alpha parameter controls the strength of the regularization in lasso regression. A higher alpha value increases the penalty, pushing coefficients closer to 0. A lower alpha value reduces the penalty and allows coefficients to have larger values. The alpha parameter in this model is set to 1.0. This means there is a significant amount of regularization in effect. This will lead to smaller coefficient magnitudes compared to a lower alpha value or no regularization at all. The coefficient for size is 0.12. This tells us that for every 1 unit increase in house size, presumably square feet, the predicted price increases by 0.12 units, holding other factors equal. A positive coefficient indicates a direct relationship. We're evaluating how well a lasso regression model, a type of statistical model used to predict things, is performing. Think of it as a test to see how accurate our predictions are. I'm presenting you with a multiple-choice question to test your understanding of the lasso regression. It's a fun way to check what you know. This question is all about understanding a lasso regression model. You've built a model to predict house prices, using their size and age as factors. Scikit-learn is a popular Python library for this type of work. I'll show you how to interpret the results of your model. The model found that as houses get older, their predicted prices tend to go down. This is what the negative coefficient for age tells us. All other factors being the same, an older house will be predicted as less valuable. Interesting, right? The model suggests that bigger houses generally command higher prices. The positive coefficient for size confirms this. Larger square footage means a higher predicted price, given all else is equal. Alpha is a parameter that controls how much the model simplifies itself, regularization. If you set it to 0, the model becomes identical to an ordinary least squares regression, OLS. OLS is a simpler model without regularization. This is incorrect. Increasing alpha actually makes the coefficients smaller, pushing them towards 0. This is because a larger alpha increases the regularization strength, simplifying the model. That's a common misunderstanding. I'm analyzing a lasso regression model, a statistical method that's really good at predicting things by finding the most important factors and minimizing errors. It's like a detective finding clues, but instead of solving crimes, it's figuring out house prices. This question tests your understanding of lasso regression and how it's used to predict house prices based on characteristics like age and size. We'll see how well you interpret the results. I'm using a specific tool, scikit-learn's lasso regression, to figure out house prices. I found that the age of a house decreases its price, and the size increases its price. The alpha value, which controls how strongly the model punishes large numbers, is set to 1.0. Because the coefficient for age is negative, I know that older houses are generally predicted to have lower prices. That's a direct interpretation of the model's results. The positive coefficient for size tells me larger houses tend to have higher predicted prices. This is another straightforward interpretation of the model output. If I set alpha to 0, the lasso regression becomes just like ordinary least squares, OLS, regression. Alpha is a tuning parameter that adds constraints. Setting it to 0 removes these constraints.